Hi everyone. Let's start with now question number 36 to 40. This is a very important questions here, and it's often asked repeat from this concept. First question is, in the structure of diborane there is structure of diborane. So what you have to know, structure of diborane is very easy. You know it is B2H6 means B2H6 B2H6, you know the structure. It's very easy question they have been asked, but now as the SLET pattern is following the trend, now you can see the 2 bridge and the 4 terminal, therefore 2 bridge and 4 terminal is very easy, but this will never ask again. What's the important now is that you see here this boron to hydrogen there, this boron to hydrogen here, this is what 3-centered 2 electron, right? Species means 3-centered 2 electron means electron deficient bond, right? This means it is an electron deficient bond, right? Next you see this BH, all the BH bond, right? 4 BH bond, right? This BH bond is nothing, this is an 2-centered 2 electron, right? 2-centered 2 electron means electron sufficient bond, right? Electron sufficient bond, right? Now what you have to know, B boron is in sp3 hybridized, this boron is in sp3 hybridized. Okay, now this angle and this angle, suppose this angle is alpha, this angle is beta. Suppose this angle is alpha, this angle is beta, then you should know the angle of beta is greater than angle of alpha. This is also important. Another important point is that it has two bridging hydrogen in a plane perpendicular to the rest of the 4 hydrogen. What I'm saying that it has 2 bridging hydrogen in a plane perpendicular to the rest 4 hydrogen, right? This is very important. Another important point is the bridging hydrogen are stronger than the terminal hydrogen, right? You should know what I am saying, that bridging hydrogen means bridging BH bond are stronger than terminal, right? Next you should know that the bridging BH bond are stronger also, then they are larger also than terminal. Okay? They are stronger also and larger also. One more thing you should know, point group is D2H, right? And the compound is diamagnetic. This is also important. Now more important is 1H NMR. How many peak? 1H NMR, there are 2 peak, and 13 boron NMR, it is 1 peak. This is the important you should know about diborane. This is sufficient. Next you see mesh the column. For mesh the column, as you see, the Rosen salt and others are given, like Wilkinson catalyst, JC salt, and Ziegler-Natta. You already know Ziegler-Natta, already repeated, you know titanium, right? Last video we have discussed, right? Next you see Wilkinson, all the famous, Ziegler-Natta, PT, you know, and Rosen salt remains the Rosen salt, right? Very easy. Now other compound you should know, like cacodyl oxide is the first main group organometallic compound. Is the first main block organometallic compound. You should know this. it is oxygen, arsenic, CH3, CH3, arsenic, CH3, CH3. You should know this. Okay, and that you should know Coleman's reagent. Coleman's reagent you should know. Coleman's reagent is FeCO4 2 minus. Another Wilkinson already given. Another is uranosine, is very famous nowadays. Uranosine. We'll study metallocene overall, but uranosine is the important. C8H8 whole 2 U plus 4. Okay, this is very important. Now about if you want about JC salt, that is important. JC salt is also very important. You have to know about JC salt. About JC salt, you should know important. It's a diamagnetic. It is a diamagnetic, square planar, oxygen state +2, and then you remember this structure is like this, na? Cl, Cl, here it is double bond, Cl, right? Here, minus. Now this all the Cl you are seeing, all PTCl bond length are not equal. You remember these are not equal. These all are not equal. Why they are not equal? Due to trans effect. Why? Due to trans effect. Very important point. Next, as you know, the CC bond length of ethylene is larger than free ethylene. Very important point. This is CC bond length of ethylene. This ethylene, CC bond length of ethylene, this is larger than the normal free ethylene. Okay, you should know. Next point. On the next, you see true or false. On the basis of the weight rule, the structure of the Fe4CO12 C2 minus is very easy. Just you know you have to count the total valence electron, right? Total valence electron 8 into 4 plus 2 into 12 plus 4 plus 2. How much it will be? 8 4 is 32 plus 12 is 24 plus 4 plus 2. Right? How much will be? 4 5 6 7 8 9 10 and 12 2, right? 4 5 6 7 8 9 10 11 12 2 remaining 1, right? 62, right? 62 is it 62 tetrahedral? So for this you should know some important you remember this: 18 42 60 62 64 72 74 84 86 90 112 120. Remember this. This is cube, this is square antiprism, this is trigonal. Very important. Every year it is asked. Prism, this is famous octahedral, right? Octahedral. Next, this is bicapped tetrahedron. 74 is square pyramidal. 72 is TBP. 64 is square planar. 62 is butterfly. 60 is tetrahedral, right? 60 is tetrahedral. This is trigonal, planar. This is mononuclear. Now we have found 62. 62 is butterfly. 60 is tetrahedral. Therefore, this is false, right? This is false. This is false. Next, you see Fe3CO4 has spinal structure. So you should know about this spinal structure. So now you know the basic spinal, there is normal, right? There is normal spinal, one is inverse spinal, and there is mixed, right? Mixed. So normal, it is all a type. What is the type? It is AB2O4 type, right? So you have to know this also. A, which that is formed, this is in 2 plus tetrahedral, 2B OH octahedral, 3 plus and 4 O2 minus. This is for normal spinal. And then for this you just shift, give one B to the here and A to here, and what it will be? It will be in inverse. You see, B tetrahedral as it is, you are giving B here, it means this is now 3 plus, right? Now here you are giving A, you are giving B, you are giving this B here, right? Then B is in plus 2, right? This is plus 3, right? And then this is all octahedral, then 4 O2 minus. Now you should know about contribution also. Contribution for this, for AT 2 plus 1 by 8 of tetrahedral void, you should remember this. And for B octahedral, 3 plus, there are 2, right? It is 2 times, it gives 1 by 4, 2 no 2, it gives 1 by 4 of octahedral, right? Octahedral void, it means it comes out to be 1 by 2 of octahedral void. This is important. For here, you know, A octahedral, right? A octahedral void, this now A octahedral void plus 2, this octahedral how much? 1 by 4, right? Just now we got. And B 3 plus, this is tetrahedral, right? For tetrahedral it is 1 by 8, tetrahedral is 1 by 8, right? Again one more B is there, right? B3 plus, it is octahedral, it gives 1 by 4. You remember this. Now how you normal spinal, how you come to know a normal spinal? If the CFSC value of B is greater than A, then it is normal spinal. If CFSC value of A is greater than B, then inverse spinal. Okay, so now one more thing, you know that if both are non-transitional element, then it is normal spinal. You remember, not if both the means both A and B are non-transitional element, then always normal spinal, right? Now in our question there is given Fe, what is given? Fe 3O4, it means one is in Fe 2 plus, other is in Fe 3 plus, right? You have to consider one is 2 plus, one is 3 plus. You calculate the CFSC. CFSC, this is D6, right? Iron 8 means 3D, 4s2, 6, right? Fe2 plus means D6, and then this is this will be D5, right? So D6 D6 means 1 2 3 4 5 6, 1 electron field, right? Here one unpaired electron here, 1 2 3 4 5. CFSC, how you calculate? You know already CFSC to calculate. Only one, right? Up is 0.6, right? 2 electron into 0.6 minus, here you got 4, right? 4 into 0.4, how much you find? 1.2 minus 16, 1.6 means 0.4, right? 0.4. Now for D5 you can calculate CFSC. CFSC equal to, you see, how much? 1 2, right? 2 into 0.6 minus 3 into 0.4 means 12 minus 12, this is 0, right? CBC here is 0, here is 0.4, right? Means we found that if CFC of Fe2 plus is more than Fe3 plus, right? It means what does it mean? Means A is greater than B, right? A is better than B means what? CFC of A is greater than B means what? It means it is inverse panel, right? For mix, what you do? For mix, you remember, for mix it is MnFeO4 and MgFe2O4. Remember this. So we got inverse. So in the question, this is an inverse, this is true. It means this is true, this is true. The answer will be C, right? Now you see thiocyanate react with Fe2 plus to form a highly colored species. This is from NCERT book class 11 equilibrium chapter, Lee Chatler principle, the application of concentration. There it is. Actually you can find it should be Fe3 plus. Okay, the doping of the germanium with arsenic give N type. You already know N type, P type, right? Let me just give a brief. You know that Kartif C Ganesh Parvati Nana Patika sorry Bindas Boron Mingan Gaza in Tela. What is saying that germanium with arsenic. Germanium with arsenic, right? This N means this is N type, right? This is N type, this is P type. You remember like this, N means N type. So this group is, when this group is dropped here, then it is N type, right? So it's N type, it is true, right? It is true. It's very easy. You remember this one, from here you study this one, temperature and Fermi energy level relation. If temperature increases, then Fermi level energy decreases for N type. Similarly for P type, it increases, right? You need to understand this. This is enough for all, right? Next, let's see. Next you see what is given. Bonding between the soft acid and the soft base is predominantly covalent. The low region given is the low oxygen state, larger size and the easily polarizable of the soft acid favors pi bonding with soft bases. This is what are true and it's a correct explanation. Now see, as you know, for hard it is ionic, for soft it is covalent. Therefore it is true. First line. Achha. The reasons you see here, I will differentiate it better. Hard, soft. Remember, hard means small size, high electronegativity, high oxidation state, low negative value, not charge, low polarizability. Polarizability, how you know? With respect to size, right? Low you write it, polarization. Next, very important, difficult to oxidized. Very important point. For soft, you remember what? There is a large size, low oxidation, low electronegativity, low oxidation state, then high negative charges, then high polarizability, then easily oxidize, right? You remember this. And one more thing you should know. Okay, we'll more we'll discuss later, more examples. Okay, this related to this concept. Now as you see, very important, this is already asked in this year 2026 SLET, or the nickel complex, right? See, similar topic. Compound, the following compound will have orbital contribution to the magnetic moment is. Now orbital contribution, you should know orbital contribution. How you will know? If T2Z is unsymmetrically filled, then you say it is an that orbital contribution taking place. Now for first example, it is given that this is given in this form, so you have to write in a complex form. We can write this H2O whole 6, right, Cl3, right. It means chromium 3 plus complex, right. It is octahedral, right. Chromium 3 plus means chromium means 3d 5 4s1, 3 plus means 1 gone, 2 gone, d3, right, d3. So you draw d3 1 2 3. So as you can see, this is T2z, this is EZ, right. Then T2z is symmetrically filled, therefore this will not the answer, right. In this way you have to go. You consider, suppose you consider B also. B, you can see, you can write in this form MnH2O whole 4, and it is given SO4, right. In this form we have to write, rearrange this. Now you see it is tetrahedral, right. Then it is in Mn2 plus. Mn2 plus means 3d 4s2. Mn means scandium, titanium, vanadium, chromium, manganese. Chromium, manganese. Next one means 3d5 4s2, right. Then 2 plus SO4 2 minus, right. 2 plus, it means 2 gone, d5. d5 means you already know it tetrahedral, so EG will down, TTG will in the up, right. 1 2 1 2 1 2 3 4 5, right. You can see T2 is symmetric, right. T2 is symmetric. Here T2G is symmetric, right. We want unsymmetric, right. This is also not the answer. Now let's check for this CO CSO6. Here we see CO3 plus, it should be 3D, this is 6, right. 2 gone, from here 1 gone, it will be 6, right, not 5, 6. Then 1 2 3 4, 1 2 3 4 5. So it will be pairing, right. 1 2 3 4 5 6. I'll write it again. So 1 2 3 4 5 6, and this is T2Z symmetrically filled, right. So therefore the answer should be C. Thank you.